Okay.
Okay.
Okay, hang
I'll
on.
unmute them.
Okay. We should be live.
Okay.
Okay, hang on. Okay. We should be live.
Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. From today will all be recorded. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. Today will all be recorded. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. Today will all be recorded. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. Today will all be recorded. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. Today will all be recorded. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell, and I'm the Global Event Manager here at Percona. Today will all be recorded. Hello, everybody, and welcome to Percona Tech Days for MongoDB. My name is Bronwyn Campbell. Hello, everybody. Bronwyn Campbell here. I think that we had some slight technical issues with getting started for our Percona Tech Day for MongoDB. So apologies for that initial interruption. First up, I am delighted to present to you Vinny Grippa, who is our Senior Support Engineer here at Percona. So Vinny will be presenting on MongoDB in the cloud. So Vinny, over to you.
Hi, everyone. My name is Vinicius. Thanks for the introduction, Browning. So I think we can start with the presentation, right?
Yeah, please go ahead and share your screen.
Let me share my screen. Can you confirm that you're seeing in full screen?
Yep.
That's awesome. So welcome, everyone. It's a pleasure to be here with you. Today, I'm going to talk a bit about, for those who are intending to move to the cloud, what are the points of attention, what you need to take care of, and I will be open to questions in the channel. We have also a Slack channel, so you can reach us at any time. Okay. Moving MongoDB to the cloud. That's the main topic. Probably everyone. So first, let's talk about me. I'm a support engineer at Percona for 3 years now. I've been most working with MySQL and MongoDB. I've been in a few conferences before COVID, and now we are doing everything online. So yeah, for those who knows Percona most because of MySQL, I wanted to mention that we work with Postgres and MongoDB as well for a long time already. So I tell you this because most of the time Percona is well known for MySQL, but we have all those over in this database. And let's start talking briefly about MongoDB in the cloud, what we can get from it. First, what are usually our hosting options? So our hosting options, what we usually find is, or you have your MongoDB on premises. This means that it's running inside the company on your own data center. You have the server running, usually hardware. You have a physical server, a bare metal instance, or you can have even a virtualized instance inside your company, or which is very common nowadays, to have cloud providers such as AWS, Azure, and Google Cloud, to mention the top 3. Hosted databases, like you can use Object Rocket, Hackspace. There is also DigitalOcean as well. So these are the options. And there are those who want to have hybrid environments for a lot of reasons, like avoiding a lock-in in a single cloud vendor, or amplifying its high availability, or whatever the reason you might have. So there are some scenarios where it is really valid and really common to have these hybrid scenarios. Some reasons that people, when DBAs and executives, the company decides to move to the cloud. Cloud in general is cost effective. So why I'm saying that, you don't have to worry about maintaining your data center. And this has a lot of things such as air conditioner, electricity, hardware that gets old with time, or you have failures on the disks and things like that. Another thing is even with technical people, like you don't have to have a person dedicated to the storage, to security and everything. So you can have an efficient IT team in your company. And that's the same reason for security. So the cloud providers nowadays already provide private networks. You can implement VPNs. They can create certificates for you, all these things. And maybe the most interesting for global companies is the fact that your database, your data can be dispersed in different locations, not only cities, but even continents. And MongoDB, because of its asynchronous nature, it works much better than environments like MySQL group replication or Galera that are synchronous. So they have this advantage. And also, when we are talking about service managed database, you have solutions for backup, restore, failover between availability zones and things like that, which is, if you would do it manually, do it in-house, it would cost a lot. So it's only a few big companies that can afford that. So when we start planning it, just a second. So what we need to consider in the strategy planning. So when you are moving from your environment, you need to take in consideration, mostly for MongoDB, CPU, memory, and disk. This is really important to evaluate, because we want to avoid any disruption in the service, not only during the migration, but also after. You need to consider the high availability strategy that you're going to implement. So are you planning to use only in, I'm going to mention most specific AWS terms, because it's the biggest cloud provider, but the idea here applies for anyone, right? So if you have any question regarding specific about Azure or Google Cloud, just reach on the channel and we will help. So if you want to do by region, in the same city, or like in the same in different availability zones, or if you want to scale it across the globe, maybe your application, you have a big company and your application needs to connect in different parts of the world, you can consider that. A really important thing is the security design, because we have many news regarding database breaches, and MongoDB in the past was starting without authentication, and this could expose like terabytes of data to the internet. So it's really important at this moment to consider the security design, encryption, not only as a network encryption, but REST, and also on the client side as well. Percona, the Percona distribution brings some features that are present in the enterprise or only on Atlas, which is a paid version. Percona distribution provides it for free. just to make sure for everyone that is watching this, the Percona business model is not based on freemium software. Our services, we make money through service like support and managed service. So any software that you will be using from us, it's completely free, fully available with all the features. There is no enterprise version. So the next 2 points that you need to consider are, first one is the migration and rollback strategy in case something fails or you do not achieve the desired performance and you need to roll back. We're going to discuss it. And also you need to include in this the backup and recovery strategy. If you don't have one, it's good that you start considering it. So what are the strategies to migrate? Actually, we have two strategies, and they are actually quite simple for those who are familiar with Mongo, but we're going to see some specific things about those. So the first strategy, in this case, again, AWS, but this really does not depend of the cloud provider, is adding a new replica set member on the cloud. And why I like this strategy the most, because you don't have downtime, the rollback is really simple, and you can evaluate how the node is behaving when the node joined the replica set. So it's really nice because you have a lot of options to test before doing the live migration. So how do we do it? First of all, we need to make sure that your DC, your current cluster, can reach the destination. So if we're using the default port 27017, they need to communicate in both ways, and not only a single machine on the source, but all machines on the source needs to reach the destination. And basically you do rs.add for those who are familiar with. It's just a command that you need to input the host name and the port, and the node MongoDB automatically starts the initial sync, and after that synchronizes. After Mongo 3.2, if I'm not mistaken, MongoDB sends the OP log to the destination, so it will perform the initial sync and the incremental. There are small chances of this failing because you will not be capped by the limit of the OP log. And after the initial sync is completed, you just need to do the rs.stepdown, and the primary will switch over. Just make sure that you have enough, the priorities higher on the destination, on the cloud. Otherwise, it will switch over to another node inside your DC. I'm not going very deep technically here because I don't have much time, but that's the basic principle. And the other thing is, if you are using a MongoDB driver, the driver is smart enough to detect these changes on the replica set, and it will redirect the connections automatically. The second strategy is the one that I don't like much, but sometimes it can be faster because it happens on the physical level. So what we do is you take a backup of your current instance. First, shut down it if you are planning to do a rsync. If you're using Percona Hot Backup, for example, you can do it live with the database running because the backup is consistent. Then you send to the cloud, and you will start the instance there. You configure the whole instance, all the procedures, redirect your application to the new cluster, and it will start working. Why I don't like this strategy too much? Because the rollback is complicated. You already started writing data on the destination, and then you need to do a rollback. It's hard to perform like copy what was written before you do the switchover. So you need to be really sure that everything is working. It's very well tested if you decide to use this strategy. Now, what are the attention points? We discussed the strategies. We see that it's actually quite simple. MongoDB makes our life really easy. But what we need to take care, and what was the issues that we at Percona observed when our customers decided to do that. So these are the 4 points that usually come to us, which is latency, downtime, security, and performance. Kind of latency and performance will feel in some situations they will have some common things, but let's see. First, let's talk about latency. It's really common when you go to the cloud that we start having problems with latency for writing or for reading. And why? Because MongoDB has read and write concerns now. And to ensure, like if you're using majority for these options, majority will require that knowledge of majority of the replica sets. And if you have 3, it requires 2 nodes. And with the increasing latency of a few milliseconds, the application can really stall to read and write. So it's really important to have this in mind. Another thing is, if you're using shards, the config servers, they use write concern as majority. So when you start migrating the config servers, you might run in this issue, especially if the application is moving chunks and the balancer is enabled. Other thing is, you were running your application the entire life in your data center with a local network and really high speed, because the servers, usually they are on the same rack or they are virtualized in the same physical host, and everything happens really fast. And when you go to the cloud, the application is not in the same place. And then again, you were performing things with 1 millisecond, and now you are performing writes and reads with 5, 10, 20 milliseconds. This is 5, 20 times more slower than you usually had. So it's really important to have these metrics, take these in consideration when you are moving it. Next one, downtime. I said before, but especially shards are really hard to move. If you shut down the shard and send it like through our sync, the rollback, if you want to, if the data that was written has any, you need to recover this data, you are going to have a lot of problems. So the strategy needs to be well planned. Again, I would suggest for especially shards to add the replica sets of each cluster that belongs to this sharded cluster and moving it slowly. You might need to take in consideration latency, but maybe disabling the write concern during that time using local for both reads and writes or something like that. But because it's really painful, shards have tons of data, so it's really important to think about it. Next, what else? Security. So it's really important to take care about security. Unfortunately, nowadays, I see databases that are running into this issue. They're completely exposed. They don't have authentication running. They are using weak key files, for example. So if you go to the cloud, it's extremely important to take this in consideration. My two recommendations, three actually, is consider setting the database servers always in a private network, never with the port exposed to the public IP. So this is going to solve a lot of problems. Also, if you're using default port and you need to have your database exposed, change it, try different ports, because there are a lot of, I'm not sure if the correct name is crawlers, but they keep scanning the ports and doing a brute force test. The last attack that we heard about, the Meow attack, it exposed a lot of database because of this, which is actually quite simple, like default port without authentication. So that's the basic. Also, using SSL with certificates, and always use the principle that the user must have only necessary privileges. Don't give root to the application. Don't give root to the users. Make the privilege only what is necessary. Next, the thing is, monitor your environment when you are migrating it, because it's very common to see, like, we have complaints like, my database is slower now, but we do not have metrics from the past. So your database is slower now. Why? Is it CPU? Is it memory? Are the disks that are slower, or latency, or it's simply you're feeling that, oh my God, the things are new and I'm not feeling comfortable yet. And you know, like there is always also this personal issue. It's kind of funny, because if there are many times like that I get, oh, my environment is lower, and then we started comparing the data and the environment is the same or it's better. So even the guy, like, maybe he's working from home now, and it's his internet that is lower. It actually happens more than we would like. We are approaching to the end. So what are the things that we should definitely not do during the migration? So these are the three things. The last one, I know you may sound like I'm being controversial, but I will explain, don't worry. So what I do not recommend to do is upgrade or downgrade your MongoDB version when you are migrating it. Why? Because it's a lot of changes happening. You are going to new machines. You are going to a completely different environment. And for more experience that you have, we do not recommending changing many things at the same time. Why? This is because if something goes wrong, we don't know what, from everything that we did, what is wrong. And if something is good, we don't know what we did that is good, because it's many things. The same applies for the driver version. Do not upgrade the drivers during the migration. Do this on a second step. It will be much better. And this is on the application side. Don't deploy new codes. My recommendation is freeze, move, check, validate, unfreeze, and apply the suggestions. And the last one, I know it's a bit controversial. There are some things that you need to change on the operational system. But when I say do not adjust, is do not try to change that specific TCP parameter like keep alive at this moment, because it's really dangerous. You will not know if this issue is happening because you changed this parameter in specific or not. So only apply the best practices and let the system goes live, and after a while you run it. Okay. I think I spoke too fast. Sorry for that. I wanted to show everything. You can reach us in the chats. I wanted to mention Percona Live that's going to go online as well on 2021 of October. Don't miss it. We are going to have great talks in more detailed content. Brian can talk about it more. And many thanks for everyone for this opportunity.
Okay, Vinny, thank you very much for presenting for us today. If there is any questions for Vinny, please feel free to use the Slack chat on the Percona Live Online Slack channel, and Vinny will be more than happy to answer some of your questions there. So just before we get on to our next speaker, we did have a slight issue with audio at the beginning. So I just wanted to mention a couple of things. We have had some questions in relation to the sessions being on demand. So the sessions are all being recorded, so they will be available shortly after the Tech Day conference ends. And we will upload them to our YouTube channel. So if you click subscribe, you can be notified then when the videos have been uploaded. Okay, so I'm going to bring you over to our next speaker now. Barrett Chambers is going to be joining us. Barrett, are you there?
Yep, I'm here. Hi.
Okay, perfect. Are you ready to present?
Yes, I am. I'm going to put a virtual background up to hide my messy room. I'm sure people understand working from home now.
Absolutely.
Let's see.
Okay, we can see your screen.
All right, great. I think my talk is a good transition from the last one about migrating to the cloud. I'm Barrett Chambers. I'm a senior solutions engineer with Percona. I talk to a lot of our customers and future customers about their initiatives for migrating to open source databases, and MongoDB has been an extremely hot topic recently. I think a lot of people are searching for alternatives to their enterprise model. They're getting pretty aggressive with their commercial licenses and vendor lock-in, and that's sort of anti-Percona. So we offer another solution to that. And it is something to consider when you're undertaking a large migration project like a cloud migration, for example. You should also probably evaluate your technology choices when you're doing something like that. Obviously, as Vinny said, not replacing everything all at once, but making it a component of that project. So I think it's important when you're trying to decide kind of path forward on the MongoDB server side to understand the history of MongoDB, as well as the history of Percona. So I'll go into how we got started in MongoDB, and I'll also go back in time on the MongoDB Inc. side. I think some people might be coming to MongoDB new within the last 3 years or so, and they're kind of unaware of how it's evolved over time. So I'm going to try to highlight the major milestones there. And then we're going to evaluate the server side specifically. So these are the areas that come up very frequently when we're talking to our customers about features that they need to run an enterprise-grade solution on MongoDB. There's also other considerations, which I think we have talks today that are going to be addressing, like automation and going a little deeper into LDAP, but I'm going to try to hit the high points of basically requirements to be running MongoDB and satisfy your security and compliance folks. All right, so history. So when MongoDB first started, 2009, 2013-ish, they were really branding themselves as a NoSQL alternative to structured query language like MySQL, Postgres, even the big guys like MS SQL, Oracle. And they were pitching this towards developers because it was in a familiar language, JSON, as well as a flexible schema model. Developers kind of didn't like how they couldn't add things on the fly. New app functionality required changes to those structured tables. With MongoDB, they said you don't have to do that. You just insert new stuff and it's fine. That's not best practice. It's best practice to plan that out, but it is possible with MongoDB. Another thing they addressed, which was a pain point on the SQL side, was scalability and high availability. There were a lot of proprietary solutions that handled this on like the MySQL side, but there wasn't really anything out of the box that you could implement to get like, let's say 4 nines or something like that. You could custom script with failover, things like that, but MongoDB introduced this out of the box with their replica set model. So they really are solving these problems on the database layer without additional consideration. And the last one was performance. So they very aggressively pitched in the beginning MongoDB's increased performance when compared to a MySQL or Postgres solution. And really that came with the previous bullet points, which is a flexible schema and scalability. So they were not rigidly enforcing data consistency and write consistency, things like that. They've since added those features and become more like rigid with it. They introduced like transactions across replica sets that are ACID compliant. But in the beginning, that was not really a concern. It was all speed, high availability, performance, empowering your developers. And they're really focused on making the database a great enterprise product. Now, that has shifted since around 2013. So about 7 years ago, they've shifted pretty aggressively to a proprietary software model. So MongoDB Server was completely open source in the beginning, but they've been slowly adding over time proprietary or commercial solutions to enhance that server. So they're still releasing the server under an open source like license, but 2013 switched their name to MongoDB Inc. from 10gen. 2015 introduced Ops Manager, which is a commercial solution, handles automation monitoring for your MongoDB deployments. And they also introduced Atlas that next year. So Atlas was sort of like an Ops Manager, but specifically targeted for cloud environments. 2016, Compass. That was empowering developers through a graphical user interface to run queries against the MongoDB interface, do data analysis, that sort of stuff. That is a open source solution, so you can use that without the proprietary license. 2017, they went public on NASDAQ, so they're growing this business, getting more people on Ops Manager, more people on Atlas. Then they started to kind of battle their competition, I guess, around 2018. So they acquired MLab. MLab was offering a similar to Ops Manager solution for deploying MongoDB in a database as a service-like infrastructure. Then that same year, they switched their license for the actual server. So MongoDB community switched from a AGPL version 3 to a SSPL. And if you're not familiar with SSPL, it stands for server-side public license. And there's a whole bunch of legalese there, but essentially what they were trying to do is prevent cloud service providers like MLab or Amazon or Microsoft from taking their code and offering it as a service to their cloud users. So now there's language in there that says if you do that, you have to open source your whole platform. And that's sort of like a deal breaker for a lot of the cloud companies who are trying to make that stuff proprietary. So your options at that point are to fork an AGPL version. So previous old versions of MongoDB have that AGPL still, or work with Mongo to establish some sort of commercial license payment to offer it as a service. The last two things, Kubernetes operator, enterprise on the MongoDB side, that's utilizing the functionality that they developed on Ops Manager to give their customers a Kubernetes deployment model. And they also acquired Realm, which is specifically for mobile apps. So they're kind of trying to transition or position MongoDB as sort of a backend to empower mobile app developers. And to accelerate that, they acquired Realm. So I tried to highlight on this slide all the commercial offerings at MongoDB, and you can see it's quite a few. And as you standardize on this over time, you owe them, just increasing amounts of money, and you're kind of no longer running open source software at that point. The SSPL was rejected by Open Source Initiative as an open source license, and Red Hat also does not recognize it as an open source license. So technically, you can use the code for free, but it's not officially recognized as open source. All right, so that takes us to Percona side. What has Percona been doing in the MongoDB space? So MongoDB started around 2009. We got into MongoDB space with the acquisition of Tech in 2015. Tech had a fork of MongoDB, which used a fractal tree storage engine. With that code and the expertise that we were able to gain from the Tech folks, we were able to create Percona Server for MongoDB that same year. So it followed our same model on the MySQL side of having a drop-in replacement of the upstream version. The next release, 2016, Percona Monitoring and Management. So this was sort of giving some of the functionality that MongoDB users were used to on the Ops Manager side, in terms of monitoring and alerting and visibility into your MongoDB infrastructure to our users. So it is a graphical user interface. Vinny showed a screenshot of it in his presentation. Definitely recommend it if you haven't checked it out. There's a deployable AMI if you're in Amazon. So 2019, we released our Percona Backup for MongoDB. This is our backup solution. A lot of the community as a whole really wants enterprise backup solutions similar to what Ops Manager provides. Ops Manager makes it really easy. It's like one click, kind of incrementally back up your database, have snapshots, that type of stuff. So we feel the need to produce an open source version of that. That's sort of our inspiration for everything. If it doesn't exist in the market and there's a need for it, we want to kind of fill that gap for our community and our customers. We also released Kubernetes operator for Percona Server MongoDB. We have a little bit of a different approach to that. We're building the logic for automated backups, recovery, node expansion deployment. That's all being built into the operator itself. So it's not calling any sort of third-party system. MongoDB is sort of using Ops Manager, so it is kind of speaking outside of the Kubernetes land to handle some of that automation. We want to kind of make that all within the operator so it's easy to deploy anywhere. Last one, 2020, Percona distribution for MongoDB. This is a complete package of all of our MongoDB tools available in one distribution. And this just ensures compatibility and proper versioning when you're deploying within your environment. So all of these tools, Percona side, open source. We do have to pull down MongoDB's server-side public license for the server. And that's a result of just us pulling down that version every time. And I'm going to go through how we built that. This slide kind of shows you strategy for MongoDB Inc. as well as Percona. I like these quotes. Basically, Dev on the MongoDB side, he recognizes that the community version of MongoDB is really just a freemium strategy for them. They don't necessarily want influence from the community on their server. They really use it to drive adoption of their commercial solutions. On the contrary, our CEO, Peter, says he sees a lot of so-called open source companies in the market. They advertise as open source, but once you get talking to them, it's like you can't really run this in production without these enterprise features, and it requires a license. So the founding of Percona was around fully open source solutions. He's continuing that today, especially on the MongoDB side. So our goal is to provide a fully open source solution. So I was talking about the SSPL. We do have that on our Percona Server version, and that's because of the way we build Percona Server for MongoDB. So every time a new version of the community comes out, we pull that version down into our own dev test engineering efforts. So we start with that, and what you get from that is the power of MongoDB's engineering on that community version. They're actively patching, adding enhancements to the community version, but then you also get Percona's engineering efforts. So that includes bug fixes, scalability enhancements. So an example of that would be our memory storage engine for MongoDB. Enterprise features, we add features and enhancements that we feel and our customers feel are necessary for running an enterprise-grade MongoDB solution. So that includes things like LDAP integration, wired tiger encryption, which I'll go into those one by one in the next few slides. And also community features. So there's some features available in the community that we add. One example of that is the hot backup feature within Percona Server for MongoDB. That's from Wired Tiger. So MongoDB Inc. acquired Wired Tiger. That's the de facto storage engine now for MongoDB. But it also had a hot backup solution in it, and that code is available. You can kind of Google Wired Tiger hot backup and find the documentation, but it's available in the community. And the last step after we kind of make our building blocks is to run it through our enterprise QA. So everything's always tested that we release through our QA, dev QA process. If it's good, it goes out. If it's not, it gets rejected and goes back through the process again. So the reason we think that you should consider this version is because you're getting the power of upstream, which is MongoDB community, as well as the power of all these open source tools and enhancements that we're adding over top. So what features are important? There's a ton of different features and tools out on the marketplace, but a few always bubble up as kind of most important to our user base based on conversations that we have with current users and then potential users as well, or people looking to get off of enterprise, things like that. They kind of let us know where we should be focusing our efforts. And most of the time this revolves around security. So I've highlighted those as important: authentication, authorization, encryption, governance, auditing, and log redaction. So we're going to step through each of these and talk about the features within Percona Server that can kind of check these boxes for your organization internally. So on the authentication and authorization side, MongoDB comes with built-in users and roles, which is good for permissions and users, but this does have to be kind of manually managed if you're using the community version. If you opt for the Percona Server for MongoDB side, you get that built-in community functionality, which is users and roles, but you also get LDAP integration through Active Directory or OpenLDAP, as well as group authorization. So that's matching those LDAP groups to roles within MongoDB without manual intervention necessary. So that's a lot more secure and usually security and compliance concern to make sure that users have proper permissions. They're not accessing things they shouldn't. They're not able to insert things they shouldn't, things like that. And then we've also added Kerberos authentication. A lot of organizations standardized around Kerberos, so that is an option with Percona Server from MongoDB as well. The next really big one that we see is encryption. So MongoDB does have some of that functionality kind of default out of the box with SSL encryption. So that's in-flight encryption. You can do that between nodes or between application and MongoDB. And that is available by default. So maybe if you're running in like a cloud environment that does at-rest encryption for you, you already have the in-flight encryption, you have the at-rest encryption provided by your cloud provider, maybe you can stick with community. What we're seeing more and more is security organizations within companies are requiring that there be at-rest encryption at the database level. So MongoDB Enterprise offers this with Wired Tiger encryption, and Percona Server for MongoDB also offers this with Wired Tiger transparent data encryption. TDE means essentially the application doesn't need to be aware of the encryption that you've done at the database layer. So you're fully managing that on the database side. This graphic down below sort of gives an idea of how that would work. Essentially, the keys are accessing that database. Application is unaware of that external key management. As long as it accesses the database, it has access to the data. This is a consideration, like you need to make sure nobody's going to be able to hijack your application because they'll have full access to that data. The upside is if somebody happens to access the server that MongoDB is running on, they won't be able to see any data by grepping data files or anything like that. They're not, that's going to be completely hidden from them. So just keep that in mind from a security and compliance perspective. This does one more thing. So this does require external key management. We recommend HashiCorp Vault for that. All right, next one, governance. This is important to make sure that there's some structure with regards to the data that you're storing for auditing purposes. You don't want some rogue developer to decide that, oh, we need to start collecting, this is probably an extreme example, but like social security numbers, and they can, with MongoDB, it's really easy just to start inserting it. You don't need to modify any schemas or anything, you just start inserting it. So there is schema validation built into the community version of MongoDB, and it's recommended to use this for sensitive data so that you have a little bit of rigidity within the NoSQL land. You don't want just rogue data being stored, especially from security and compliance perspective. Auditing, another important feature. This is the ability to audit user activity within your database. It's really important when you get audited for like SOC 1, SOC 2, HIPAA, PCI compliance, that sort of thing. This is built into Percona Server for MongoDB. It is not available in the Community Edition. It is available in the Enterprise Edition of MongoDB. So your options are, if you require those, to use Percona Server version or to pay MongoDB Inc. for their Enterprise license. Our implementation is filterable, so you can filter by user. I've showed an example of that configuration in the bottom. So another feature when it comes to logging is being able to redact sensitive information from log files. You don't want that information being written out, you know, a query with a sensitive string in it, like a social security number. So we do have log redaction built into our version, Percona Server for MongoDB. It's not available on the community side. It is available in the enterprise version of MongoDB. So that was a lot, but I wanted to provide this graphic just to kind of go down basically what we've seen at Percona, areas that you should be considering and what's important. And then potentially you can stick with community if these things aren't necessarily important for your organization. So it kind of gives you, you know, we're fine with just having SSL connections or the built-in users and roles and things like that. But with Percona's version, you get that SSPL license, same as community, but you get all the features from a security and compliance perspective that you would get with enterprise, and you don't have to pay an enterprise license. So it's available free for download from our repositories or our website. All right. Any questions?
Okay, Barrett, I don't see any questions there right now, but thank you for a great talk. If anyone does have any questions for Barrett, then please feel free to add them into the Percona Live Online Slack channel. And Barrett, I guess you'll be around for a bit to answer any of those questions. So if you do, then join into the chat channel, and all of our presenters, in fact, will be around there today. So if you're enjoying the sessions that you're hearing today, we are hosting our next big event for Percona Live Online. So that will take place on the 20th to the 21st of October. And we will be live streaming that for 28 hours of nonstop awesome database content. So you can register for free at perconalive.com. We have some great MongoDB talks as well as MongoDB keynotes, and we'd love for you to join in. So we hope that you will pre-register and join us for that. We also have our next Tech Day, which is taking place in 2 weeks' time, and that is for MySQL. You can find the details on percona.com as well for that. So our next speaker today is Sandra Romanchenko. She is a QA engineer here at Percona. So if you have any questions for Sandra, please post them into the chat channel and she will be around to answer any of those questions. But for now, Sandra, I will hand it over to you.
Hi everyone. Today we're going to talk about enterprise authentication in Percona server for MongoDB. My name is Sandra Romanchenko and I'm QA engineer at Percona. So let's start from what is Percona server for MongoDB? It's a solution based on MongoDB Community Edition with extra features and functionality built on top of it. So here on the slide, I've added a small comparison table of features available in Percona server and in Enterprise Edition. Besides community features, we have added such functionality as LDAP authentication and authorization, Kerberos authentication, auditing, log reduction, data trace encryption. We have our own in-memory engine and also hot backup, which isn't openly accessible in enterprise version, but implicitly available via Ops Manager. So why access control is so important? I think that this picture, which is one Google search, can say more and louder than 1,000 words. Nowadays, when security topics are extremely popular and important, and even tiny companies have their own security departments, there are still unprotected databases which anyone can access and just gather private data. So what we can do to prevent unauthorized access? We can enable authentication, which is basically the process of verifying the identity of a client. There are several mechanisms available in Mongo database, and the first one is SCRAM. It's a default one. It supposes using username and password. The second one is X59 certificate authentication. I think it's self-descriptive. Just please know that for using this method, secure TLS SSL connection is required. That's all for Community Edition. If to talk about Enterprise Edition and Percona server for MongoDB, there are also LDAP authentication, Kerberos, and new in 4.4, it's AWS IAM. It's not supported by Percona server for MongoDB yet, but we have it already in our roadmap. So you may wonder, why to use LDAP or Kerberos if there is a default authentication mechanism and you could just use username and password? So there is no problems with that, but you will get a list of benefits if you switch to new methods. The first one is an ability to maintain all users in one place. It's not so important if you have, for instance, just DBA or developer who needs an access to database. But imagine a situation when there are a lot of people within different departments, let's say support, sales, development, marketing, and all of them need access to database with different permissions. And it really sounds like a nightmare for DBA who needs to manage all those users, to add them and remove records when access is no longer required. But with using LDAP, it's possible to do it just in one place. Also, it's possible to force users to follow your security policies, such as password lengths, complexity. You can set expiration for your account or password. You can even lock account in case of exceeding the number of login attempts. So let's check a little bit insights of centralized authentication. And the first one is LDAP proxy authentication. So the diagram shows all steps of the process. It starts when client sends plain authentication against Mongo server, and int in its turn initiates SSL session with the client. Afterwards, Mongo client sends SSL authentication to Mongo server, which forwards it to SSL daemon, and it sends it to LDAP. When authentication is successful, the proof is returned all the way backwards. Sounds quite complicated. In addition to that, this method has its own limitations, restrictions, or maybe disadvantages. For instance, there is an external component, SSL daemon. We need to maintain it, we need to configure it, we need to ensure it's up and running as it can be an additional point of failure. But the main disadvantage is the necessity to add users in Mongo database, the same users that we have already in LDAP. This restriction is dictated by the fact that despite we successfully check user credentials, we still have no idea what permissions users have. That's why we need an ability to match username to some permissions. I will show a bit later what exactly I mean in live demo. The second method is native LDAP authentication and authorization. This mechanism excludes all minuses of the previous one. So now we avoid using excessive components, and Mongo database communicates with LDAP directly. But the main benefit here is authorization. It means that when user tries to access Mongo database, it's not only checks user credentials, but it also checks to which group user belongs. And when group is returned from LDAP server, Mongo can match this group against some role which was previously created by admin. It means that it's still required to create corresponding roles with proper permissions in Mongo database, but the number of records is just significantly reduced. All you need is to divide your users into different groups and create roles in Mongo server. Then you can add as many users as you want in LDAP. You just need to assign a proper group. That's probably all. User, in addition to that, user can belong to different groups. It means that users' permissions will be merged. So user will receive permission from both groups together. And the last authentication mechanism is Kerberos. If you may know, Kerberos is a ticketing system. So in order to log into database, first of all, you need to receive a ticket from KDC. Afterwards, when authentication request is sent against Mongo server, which is also, by the way, Kerberos aware, Mongo validates this ticket against KDC. When and if approve is returned, this approve is then sent to a client. That's probably all with theoretical part. So now let's move to a practical one and ensure that everything that I have mentioned actually works. So I will start demo from the first discussed authentication method, which is LDAP proxy authentication. I have pre-configured test environment with LDAP and Kerberos services since configuration of these services is just out of scope of this presentation. In order to use Mongo together with LDAP via SSL OSD, first we need to install SSL packages. Depending on operating system, you might use one of the provided commands. The next step will be a configuration of LDAP authentication mechanism for SSL OSD. And just for convenience, we enable automatic start of the service during system start. The next step will be a creation of configuration file for SSL OSD, where we provide the connection string to local LDAP server, together with bind distinguish name and password. In addition to that, we also need to set LDAP search base and LDAP filter, where basically the username is passed. Now we need to check whether our connection is successful. For this purpose, we will use test SSL OSD utility. We just need to pass it username and password of the user which already exists in LDAP. As we can see, connection is successful, so we can proceed with configuration of Mongo service. The first step in this case will be configuring SAS library for Mongo. We need to create a special mongodb.conf file in directory where SAS library can find it. In our case, it's etc. SAS2 directory. Here we just set regular options like path to run directory of the daemon. Next will be a configuration of MongoDB itself. We need to change in MongoDB conf authorization option and set it to enabled, and also add plain to authentication mechanisms option. In this case, plain stands for LDAP. Now we need to log into server and add the respective user. So we log into server as DBA and check just connection status to see what authentication roles were assigned. Now we need to switch to $external database, just in case it's not a real database. It doesn't store any data. It's kind of logical database which just instructs MongoDB that user is authenticated to an external service. So we switch to this $external database, and now we need to create a user. So we have added a user, test user, with permissions. In this case, I have added read permissions to test database. And that's all for Mongo configuration. Now we can try to log in to Mongo server. What we need to enter here is username, authentication database, which is $external, and authentication mechanism, which is plain. So let's try to log in. We need to enter a password. And login is successful. Let's try to check connection status. As we can see, correct permissions were assigned to a user. Now let's try to show a list of available databases, switch to test database, and check some data in test collection. All actions are successful. Now, to ensure that permissions work correctly, let's try to drop some data from test collection. And as expected, we receive an error since we do not have such permissions. And that's all for this, this authentication mechanism. So now let's move to native LDAP authentication. So in order to use native LDAP authentication, there is no need to configure any extra services or create some extra configuration files. All we need is to define proper options in Mongo config, and it will just work. Let's check out. So I have prepared the proper config file, and now I replaced the default one and restarted service using systemctl. So let's check out what's the proper config file. Here we see authorization option, which should be set to enabled as in the previous sample, and new section called own options. Servers, it's either domain name of your LDAP or IP address. The next option is transport security. By default, it's set to TLS. So if you want to disable it, you need to explicitly set it to none. Also, it's possible to define bind user together with password. Please note that you need to provide here a full distinguished name. The next option is user to DN mapping. By the way, we have a cool blog post about it on our website. So if you're interested in peculiarities, you can check it out. Basically, this option is required for cases when user enters a convenient username during login. So we do not force users to enter a full distinguished name like CN equal Mongo, DS equal Percona Tech, and etc. We want users to enter something simple, for instance, just Mongo, but we need somehow to change it to full distinguished name. That's why we have this option. There are several possibilities. We can just change the value based on what we receive, or we can query LDAP. So whatever user enters, we send it to LDAP asking whether there is such user or not, and asking us to return a full distinguished name. And the last option is query template. Here we query LDAP and ask to send the list of groups to which user belongs. And here we provide basically the user, which was the username, which was transferred and translated here. So let's try to log in. As in previous sample, just enter the username, which is test user, authentication database, and authentication mechanism, which is plain. So we enter a password, and connection is successful. So let's check out connection status. As we can see here, the user is authenticated successfully because basically there is such user in LDAP and we have entered correct password. But on the other hand, the user doesn't have any permissions assigned in Mongo itself. So as we can see, user belongs to CN DBA group, but this group doesn't match any role created in Mongo itself. So let's check out whether we can do, for instance, list databases. No, we can't. So now we need to log in again as DBA and create a correct role. So here we create a role which match the full distinguished name of the group to which user belongs and provide some permissions. For instance, in this case, we add built-in role, which is read, write any database. And let's check whether it will help us. So the same command, enter password. And now if we check connection status, we can see that we have received new permissions to read, write any database. And let's check whether we can actually do it. And we can. We can switch to test database, query data, whatever. So that's all configuration of native LDAP authentication. And now let's move to Kerberos. So the last is Kerberos authentication. The configuration is quite straightforward. All we need is to remove all previous configuration files and to add proper configuration to MongoDB conf. I will show it a little bit further. Also, the important point is to add a key tab for MongoDB. A key tab is a file which contains a pair of Kerberos principals and keys and can be used by remote system without entering a password. So it totally suits for services. A key tab should be defined in environmental variable, which is Kerberos 5 KT name. which in its turn should be set in etc. default MongoDB file. Now let's check MongoDB. Here we need to set authorization option to enabled and add GSS AP authentication mechanism. Now we need to log into Mongo server and add user with respective permissions. As in our previous case, if we authenticate using Kerberos, we still wouldn't know what permissions user should have. So again, we need to switch to $external database and create user, test user with, in this case, root permission to admin database. Now we need to get a ticket for test user since Kerberos is a ticketing system. So we issue key init command for test user for receiving a ticket and enter a password. If it's successful, a ticket will be issued. And now we can try to log into Mongo server. Here we define authentication mechanism, which is GSS AP, and $external database, and username, which is test user. So let's try to log in. Login was successful. Let's check connection status. We can see that proper role was assigned to a user. We can check the list of databases. All seems to work. So that's basically all what I have for now. I hope that for today's presentation, you will get some useful examples and tips for further configuration of your Percona server for MongoDB together with LDAP and Kerberos. Thanks for your attention and join us at Percona Live Online in October. Bye.
Okay, thank you, Sandra. So next up, we have a talk from Akira, who is the MongoDB product owner for Percona. Akira will be presenting on MongoDB backups and an overview with that. There'll be a quick comparison on the different backup solutions that can be used with MongoDB. So just give me one moment and we will head over to Akira.
Hi, everyone. Today we are going to talk about enterprise authentication in Percona server for MongoDB. My name is Sandra Romanchenko, and I'm QA.
Sorry, we have just a slight issue with this. Just give me 1 second and we will pull this talk up for you. Akira, I'm just trying to see if I can get you to join. Just bear with me. Okay, so okay, sorry, just 1 second and we will try and get this resolved. I'm just trying to get Akira.
Oh, hi there.
There we go.
Hi, my name's Akira. Let me just come up. Oh, hi, there we go. Pleased to meet you. This talk is going to be about 6 different backup solutions that are available for MongoDB. So this talk is for MongoDB DBAs. Whether you're looking to use backups for the first time or you have one solution now but you want to check if other solutions are going to be better for you, this talk will give you a quick way to compare them in broad detail so you'll be able to choose the right one and then focus on that later and study that later. Let me just share my presentation screen again. Okay. So here's the agenda. First of all, I'm going to talk about some terminology that needs to be clear and some general points about how MongoDB backups work. And then I'll start comparing the 6 different solutions. And at the end, I've got a performance comparison and a summary to give. Anyhow, let's get into it. Okay, first thing I want to make clear is what the terms logical and physical copying the DB data underlying files. Okay, another one is, and again, mostly everybody would be familiar with what this means, but consistent backup means that the copy of the data is every single document in there is as it was at some particular real time. What that point in time is depends on the type of backup system using. If you're using a logical backup, it'll be the consistent time that will be restored should be the end time of the backup. That's the only way it's possible. With physical backups, usually it's the start time of the backup that's being captured exactly. And there's some different cases there, but as a general rule, it's got to be that start time of the backup. And if you're using a point in time restore, well, the consistent time that you're restoring could be anything, any point in time. That's the entire point of having a point in time restore, is that you can pick any time. But whatever is restored, every single document will be as it was in reality at some point in time. There will not be mixed time versions in there. Another term, which again has been heard a lot, and pretty much everybody should know this already, is that a hot backup is a backup you take without shutting your database down. This kind of term is very much outdated when you have a distributed high availability system like MongoDB, because pretty much, well, every single way of doing a backup leaves the DB running. Clients can still use the database live while doing it. So as a general term, hot backup covers all the backup systems we're going to explain later. But just to put you on the same page as what it means when it's usually put in, for example, in marketing flyer or something like that, usually it only means a physical backup method that can do it in hot or live. So there's a kind of a disagreement here between what hot backup should mean and what is usually advertised as meaning. But I'll explain that more as I get to the hot backup slide later. And lastly is a snapshot. This is usually people when they talk about a backup, that's a snapshot. When you make a backup, it's a copy of the whole database. It should be a consistent one, but more consistent is another word. There are also sometimes storage engines will provide their own snapshot method. This is not just MongoDB, this is other databases as well. A storage engine snapshot is an even more tightly controlled point in time copy of data. But either way, a snapshot is a whole copy of the database, as opposed to incremental backups, which are changes in the data from 1 minute to the next. Okay. And lastly, point in time restore, again, another well-known term, but a point in time restore is not to talk about the single point in time of a consistent backup restore. A snapshot, if you restore it, should have a single consistent point in time. It's not that point in time, although that is a valid thing. A point in time restore system enables restoring to any arbitrary point in time that you want to choose since your last backup. For example, if a disaster happened at 11 a.m., 26 minutes and 13 seconds exactly when somebody dropped a collection they shouldn't have, you can choose not just to go to your backup, which was made at 3 a.m. this morning. You could go to exactly 11 a.m., 26 minutes, and 14 seconds, 1 second before the bad operation executed. The ability to go to an exact second is what any second at all is what a point-in-time restore system is about. Okay, so there are things that are used in backups. Of course, copying the whole file is making an entire snapshot as one part of it. There's different ways of doing that, which we'll come to later. The second part, most important part of MongoDB backups is using the oplog. Well, again, everybody who's joined this talk probably knows what an oplog is, and you, by all means, skip ahead a minute in this presentation if you're already up to date. But for its replication, MongoDB creates oplog. It appears as what looks like a fairly ordinary collection. You can read it. You shouldn't write to it. You definitely shouldn't change it. MongoDB is writing into it. But every single document in that is an operation that is idempotent. It could be replayed again if needed without changing the final result as you get to the end. There'll be one document after another, after each with its own separate timestamp and with the operation that is being applied to collections, both user collections and system collections, one after the other. And they come in order. The oplog is a cap collection with officially no indexes on it at all. If you try to view indexes for the oplog, you'll see nothing. But there is an enforced order. The timestamp increments and always goes forward and is never out of order. One document after the other is followed, timestamp by timestamp. And those, as I say, those operations are idempotent ones, so they can be replayed. A sequence of the oplog can be replayed again and again, and you'll always end up with the same result. So it's a very safe and nice thing, a similar concept to a redo log as used in other databases. Okay, so this exists, and of course secondary nodes are reading this and applying this on their own data using the fairly internal apply ops command. They just one after the other, apply op, apply op, apply op. So that's how replication works. But it's not just a system collection, and it's not a hidden collection. You can access it freely, pretty much with any read permissions if you have them. So this is useful in backups because a database snapshot might not be a consistent one. Logical backups will read documents as they go through, and as they go through, there'll be a spread of time. So when they begin, say at 2 p.m., the first documents they will read will be as they were at 2 p.m. If it takes until 2:30 p.m., what happens to those documents that were first read? If they were updated, that won't be in the copy, the logical backup snapshot. They'll be missing. But we don't want to have documents with different time versions in the same backup snapshot. We want that to be cleaned. But what you can do is copy the oplog that occurred during that time and apply all the operations in it when you do the restore. You don't do it when so you'd make a copy of all the documents first, then you would go back and copy the oplog at the same time and save that in your backup directory. And when it comes to restore, put the snapshot as it is with potentially inconsistent records and just apply the oplog. And that will bring them all up to an exact point in time as of the end of the snapshot. This is a very good thing about MongoDB, that the oplog is there and these oplog documents are just available to use. It's a very simple way to get consistent backups compared to older databases. Okay. In this next slide is not just about restoring to a single consistent point of time when restoring a snapshot. It's going on to point-in-time restore. In this diagram here, I'm showing several different replica sets that belong to the same cluster. One replica set for the config servers, and then a couple of shards. The idea with point-in-time restore is to keep on capturing the oplog 24/7. Make a copy of the oplog in order somewhere continually. So if you have to restore, you can first restore a snapshot, and maybe you need to use it to fix the snapshot if it was an inconsistent snapshot. But then you can continue playing forward from the point in time that the snapshot was consistent to whatever time you like. In this case, I've put a mark to time X. In this case, you would first restore the snapshot before it, and then for every single replica set, the config server and the two shards here, you would keep on replaying their separate oplogs, replica set by replica set, until you reach the same point in time. That's the whole idea of a point in time restore with MongoDB. Another part of MongoDB backups is transactions. This didn't matter until just a few years ago, because until up to and including version 3.6, MongoDB did not have transactions. Well, the storage engine has its own transactions. I mean, it maintains things like when you update a collection, it also updates an index data structure. That will be done inside the same storage engine transaction, but we're not talking about that. We're talking about transactions that users can use. They can run a command, start transaction. They can do one write and another write, and whereas there's no limit on number of writes, but they could do multiple writes and then commit transaction. And those multiple operations will be applied on an all or nothing basis. They will all be applied, or they'll time out and just be discarded. So in version 4.2, it became possible to do this, although it only applied to non-sharded replica sets. And in version 4.2, it became possible even in sharded clusters. But to get to the point, transactions are multiple write applications that should be applied all or nothing. So if there's a restore, it should apply. If it applies one, it should apply the others and run a commit. If one appears but not the others, or more to the point, there's no final commit transaction, they should not be applied in the end. Right. I will just quickly show you what a transaction looks like. This is a version 4.0. It just puts the multiple application, the multiple operations in the transaction inside one oplog document. In a 4.2 distributed transaction, one that actually involves multiple shards, it's going to be several different oplog documents. Some of these are going to be to system collections, which are fairly temporary and short-lived, or at least the documents for them are. But there are some which clearly look like regular oplog documents, and I'll explain those. First of all, this is one of these system ones that is not so important. I'd like you to focus on this one here. This is an insert to the test BAS collection, which occurs on one shard. You can see that there's a transaction number field. The transaction number here is 0. Usually it's a high number, but 0 is also a valid number. It has its own timestamp, and as well as operation, it's only marked as prepare. There's no commit transaction yet. On another shard, there's another operation. This one is into a different collection, as happens to the test bar collection. This is also just, it has the same transaction number, and it is also only in prepare mode. Here's an update into a certain, into one of those system collections, which I'm going to pass over, and show you this oplog doc. This one actually occurs in two places. It occurs on both shards. It's exactly the same one. In particular, it has exactly the same timestamp on both shards, and this is the final one that matters, where the transaction is committed. When you have this, then you'll finally write those prepared operations or commit them in the storage engine on your shard. So both of these should have exactly the same timestamp, and there will be a commit transaction. Okay, this is fairly detailed, but transactions are new, so I thought I would share this detail. Okay. Rightio. Now we come to the main part, which is where we compare the different backup options that are available. As I mentioned, there are 6. I haven't made a particularly decorative or graphical slide here, but we're going to name them and shortly look at each of them. One is probably the oldest tool that most people know, using Mongo dump or Mongo restore on the other side. Maybe the original one though was the method of shutting down one node and copying its files while it's stopped. This is a data at rest file copy situation. Another way, which is very similar, although it's a more live situation, is to run a file system snapshot. I usually use LVM to do this. So I would create an LVM snapshot of the file system while the database is still running, and then mount that snapshot and then copy the files away to somewhere else. A new tool in the history of MongoDB tools is Percona Backup for MongoDB. And a bit before that, there was also a wide target snapshot method, which you haven't discussed much, but again, it's a very similar system to the file system snapshot. Without stopping your MongoDB node, you can say, please create a snapshot copy of the files, which wide target provides through its API. It will copy files out while the database is still running. And the last one here is MongoDB Ops Manager, which is the biggest and most complex system. I put it here in the middle, and there's a reason I've done that. It's because it's the only one that straddles both logical and physical types. Mongo dump or Percona Backup for MongoDB are logical systems. Those other 3 on the top right there are physical systems, and MongoDB Ops Manager provides methods that are both physical and logical. So you can use either. Next, I'll give you a brief view of what each of these look like in case you've never used them before. Oh, but firstly, you might ask, why are there so many options? Well, there's no really great reason. It is feasible that all of these could have been built right into MongoDB and just run like a wide tiger snapshot can be run. It just wasn't done. And now that MongoDB community is not really community anymore, it's a free version, and it's an open source. You can read the source, but it's not a community project that is accepting patches, except ones for the most most serious bugs. I don't think we'll be able to make a single backup solution that is all inside MongoDB, because I don't think MongoDB is going to accept those patches. In the end, we're left with a situation where we have so many external tools because they were quicker to provide at the beginning. So I'm afraid there's just no good story. This is just how this came about. Okay, let's overview and just give you some eyes on what it looks like. First, with the stopping a secondary method, whether you can use an ordinary secondary or a hidden secondary, but simply the idea is if you stop a MongoDB node and restart it, the files that it has left when it shuts down, you should be able to restart with it. And that's one of the guarantees that a database system does. Well, yes, that's how it works. The files, when you stop a MongoDB instance, are a valid, consistent view of data. Of course, they're becoming out of date every second that you don't copy them or don't restart, but they are a valid, consistent copy of files. So just stop a node, making sure you don't stop too many, and making sure that the replica set is still okay. It still has a primary, it still has a majority of nodes. But stop one node and just copy its file somewhere else into a backup server, so you can bring them back later if you want to do backup. That's all it is. And so you simply stop your MongoDB, copy your files. In this example, I've used copying to an object store, the AWS S3 object store, but you can also copy it to an ordinary file server. Anyhow, that's all that is. Mongo dump and Mongo restore, this is a command line tool, which, as mentioned, being a logical system, connects using database drivers. It connects to a replica set node, or it connects to a cluster through the Mongo node, and it just iterates all the databases, both the system ones and the user ones, and then in each database it iterates all the collections it finds there and just reads the documents out by underscore ID order and writes them into BSON files. Now that's all it is. So you simply use that. When it comes to doing Mongo restore, you point the Mongo restore at a live MongoDB replica set or cluster, and it will just drop all the collections and reinsert all the BSON documents one by one. Well, not one by one. It does it in batches of 100 or whatever, but it conceptually just reinserts all the documents one by one. So another very command line-like solution. As is using a file system snapshot. LVM is not the only file system you can use to do this, but it's the most common one, so I'll focus on that. When using a file system snapshot, you really need either Unix root permissions, or you need your Unix system administrator to spend a lot of time making sure you've got all the necessary permissions as another user to run a command like the LV ones. Usually an ordinary user cannot do it. So there's some Unix level administration that's needed before you can use this. But when you use it, you'd use the LVM commands to create the snapshot. You'd use the standard Unix mount command to mount a read-only mount of that data. Then you would copy the data somewhere else. Then you'd unmount the snapshot and just throw it and then delete it. And then the file system can get that box space back again for other needs or future backups. So again, the file system method is a very command line system, but I wanted to point out it really requires higher than average Unix admin privileges. MongoDB Ops Manager it's kind of hard to show, but one thing that's clear is it has a GUI. It has a nice web server-based GUI that you can use. It also has agent processes that run on each of your servers. These agents can do automation, which is sort of off topic, but is part of how MongoDB Ops Manager does it, as well as doing backup and alerting and so forth. So these agents must run on every single server, and you can control the backup. Also, you must set up a backup location, but that applies to, of course, to any method. But anyhow, you can control it and you can see the list of backups that you have through the GUI. Why target snapshot is it will create a copy of the files as of a particular point in time, the starting time of when you run it. It's available in 2 different editions of MongoDB. It's available in Percona Server MongoDB, and it's also available in MongoDB Enterprise Edition. MongoDB Enterprise Edition does not document how you use it, but it's clear that there's an aggregation pipeline operator stage called Backup Cursor, and I assume it's pretty similar in that it just goes through and creates files one by one, but how it's used exactly, it's not clear. Maybe it's only used by Ops Manager and Atlas. I'm not sure. Percona Server MongoDB, however, on the other hand, is documented. We've added a command called create backup. This can either save files to a local directory or a remote server that's mounted locally, or you can send to an S3 destination directly. So you can use an object store or not. You run the command as a Mongo shell command. So you don't need special Unix privileges to make this. You just need some place to copy it. Okay. Another solution, I think the 6th one in this list now, is using Percona Packer for MongoDB. Like Ops Manager, it requires that you store an agent on each server. In fact, 1 agent for every single MongoDB node, whether it's a config server MongoDB node or a shard node or a non-sharded replica set node. You should store 1 PBM agent service for each. Those agents, though, are only part of the system. The other part of the system is using the PBM command line tool. Here I show an example of listing the backups you have, but of course, you'd also use it to run the backup, delete old backups, or to begin a restore. So this is a very command line system. There's no GUI part in Percona Backup MongoDB. Okay, so those are the 6 types that are available. I will now make a comparison, put them in different buckets, so you can choose which one you need. Okay, first of all, which one do hot backups? In a sense, all of them do. Although the wired target snapshot method is the one that's usually marketed as being called hot backup. But all of them offer you the ability to make a copy of the data without shutting the database down. This is, with MongoDB's high availability, this is just a granted these days. Point-in-time restore is only available from 2 solutions. Although if you are pretty hot at doing shell scripting, you can do it. You can do it yourself with a shell script too. That's also possible. But so far as it's built into a system, this is only available for Percona Backup for MongoDB as of version 1.3. At the time of recording this, Percona version 1.3 is going through QA and it should be released soon. I believe it will be out by the time this is presented. MongoDB Ops Manager Backup has had point-in-time restore for a long time. So, but either of these 2 solutions have point-in-time restore, which will provide consistent backups for a cluster. A cluster is an issue because the different shards and the config server, the idea is to capture a snapshot at exactly the same time, which is you can't do. You can't make guarantees when you have a distributed system. But there is a way to make their restored versions consistent. Again, both Percona Backup for MongoDB and MongoDB Ops Manager do this in the same way that they can do point-in-time restore, more or less. Before we had transactions, before we had consistent, before we had a cluster-wide logical clock to use, either the file system snapshot or a wide target snapshot were considered good enough, because that was without a shared time, perfect cluster logical time to share between. Shards having slightly different times was as good as it could get. So you may as well use a file system snapshot run in parallel on all the replica sets, or use a wide target snapshot, or as long as they started very close in time, that was as good as it get. So before 4.2, those 2 were okay, but for 4.2 onwards, you really need the internal abilities to do a point-in-time and restore system, and that's Percona Backup for MongoDB or MongoDB Ops Manager Backup. Not that it needs to be point-in-time restore, just the consistency that was available in Percona Backup MongoDB from its very first version is also enough to do that. Okay. As for how you use it as an administrator, well, top right 3 there, they're purely shell script. The other ones, you install them as external software. Although Mongo dump, Mongo restore is so simple, it's debatable whether I should put that on the shell script side. Anyhow, but there are these 2 different families. One's you do everything with shell scripts. The other one is, even though you're still using shell scripts possibly in cron jobs to start the backups, etc., they require extra software that you would install. And as for where you store them, well, using object stores is a cheaper way and can be a faster way too, depending on the service you're using. But at any rate, object stores are usually cheaper and otherwise more useful, particularly in our cloud environments these days. Only 3 solutions support it. One is wide target hot backup, but only the one offered in Percona Server for MongoDB. It's not available in MongoDB Enterprise. Otherwise, Percona Backup for MongoDB and MongoDB Ops Manager can use S3 as a destination, S3 or Minio. As for open source, there are 2 proprietary ones, wide target hot backup in MongoDB Enterprise Edition or MongoDB Ops Manager. Otherwise, they're all open source. Okay. Lastly, let's consider what you need to choose if performance is an issue, and it usually is. First of all, you've got to work out how much I/O speed you've got when it comes to writing the backups. Usually you've got an idea, oh, it's something, something, something. We'll find out when we try it, but you really have got, there's no way to have an idea. Is if it's acceptable or not? Is it going to finish in 1 hour or is it going to finish in 24 hours? It could easily be one or the other until you sort out some factors of 10. If it's 50 megabytes a second, you're going to have a bad time unless you already have a very small amount of data. But if it's 500 megabytes a second, on the other hand, it's going to be good. You really need to work it out. Also, there may possibly be a network bottleneck. Probably not, but that could also get in your way. So you really do need to figure out how fast you can write to your backup storage location. And if it's not good, time to make sure you get a better backup storage location to use. Okay, but this important public service announcement aside, let's go on to what we know about the different backup solutions that exist. First of all, logical, physical. Physical is usually faster. With logical, you can avoid some file access because for the data that is in memory. If you have most of your data in memory, this is good. But when it comes to making a backup, it can be that a logical method has read amplification. It will read the documents by their _ID order. And if the documents are small and the order of documents by which file block they're in is very scattered, it may read a 1 4 kilobyte disk block to get one document, and then read a different one to get the next document, and then read a different one to get the next document. If a document is only, say, half a kilobyte, whereas file blocks are 4 kilobytes, you'll have to read 8 separate, to get through 4 kilobytes of logical data, you'll have to read 8 separate different file blocks, 32 kilobytes. So you'll have a read amplification of 8 times. And you could easily have documents that are much smaller than that. I've seen an extreme example where it seems as though by what we could tell from the metrics, it was reading 100 times as much disk because of scattered disk block reads as the size of logical data. So that can be a problem with logical backup systems. They can do a lot of read amplification on the disk, and physical doesn't have that. It may not matter, but if you have very small documents and the documents were inserted in a very random fashion, there could be a lot of read amplification, which physical will avoid. On the restore side, again, physical is usually faster. With physical, though, you'll be stopping and restarting nodes. So that's some manual time that will be required to do that. Logical, on the other hand, doesn't do that. You can just restore straight into your running node. If you're happy to overwrite what you have at the moment with the backup data, you can just restore straight into there. This is a minor time saver. Usually physical snapshots restore faster. Okay, in summary, okay, if you happen to have a small database, nothing wrong with using MongoDB, MongoDump. So long as you don't need point-in-time recovery, that is. Don't forget to use the oplog options as you do it, as you make the backup and as you do the restore. Otherwise, you won't get a consistent data view. But although I'm not going to usually use MongoDump, if you have very small data, this is quite okay. In the medium small to medium, up to medium large, physical speed is, despite what I was saying in the recent slides, it's unlikely to be noticeably faster than logical, but there are cases when it is, and you'll just have to test to find out. Now, when it comes to doing tests, if you're a cluster, just test with the biggest shard. You don't have to do all of them together. See how long that takes. Doing, say, a logical method, just MongoDump would be fine. Compared to copying the files, say with SCP, to your backup storage location. Use your real backup storage location. Don't do it to local disk. That'll be that might have a bottleneck. Do copy it to the real backup server. I think you'll find that logical is usually not much faster than physical. Okay. Anyhow, well, once you've worked out if logical is fast enough for you or not, after that, your choice depends on these features, using open source or not, whether you need perfect cluster consistency or not. we didn't use it before, and you're not using transactions, and if your client application is not using transactions, it may not matter. But if you do, you'll have to use either Percona Backup for MongoDB or Ops Manager. Whether you need to use point-in-time restore, and whether you're using an object store or a simple file system backups, these filter which options you can use. Okay, about point-in-time restore, don't aim to use point-in-time restore if you have a high write churn. If you have updates and updates that are constantly changing documents without or inserting and then deleting documents, if you have a reasonably fixed size of data that's being changed a lot, point-in-time restore is not good. It's not good for you because the oplog that's created is very high. I've seen many cases where the size of the oplog per day is larger than the entire database by itself. So that, of course, implies that the amount of storage space you needs to be twice as large. And I've seen some cases where it's much, much larger. So apart from the fact you need more storage space, the backup application has to be able to accept writes much faster than usual. It can't, because it really has to keep up in time. It can't afford to fall behind. So your backup server would need to be fast too. Also, when it comes to doing a replay to an exact point in time, an arbitrary point in time, that's a huge amount of oplog that will need to be replayed, and it'll take a long time. So if you have high write churn, point in time restore is just not for you. You won't be able to do it. Okay. Lastly, what if you have a really large data? You have a huge amount of data per node. For this case, the amount of time it takes to copy data is very large. I find so far that using an LVM file system snapshot is the easiest, but you will need to allocate extra disk space. Maybe you can do it in just one node, maybe a hidden secondary, but you will need one server for a MongoDB node that has extra disk space, which will be used by the LVM volume group. And when it comes, if you do this method using the LVM file system snapshot, you'll need to also capture some extra oplog by script to replay up to the same point in time if you have multiple shards. This is the best solution if you've got a really large amount of data per node. I don't think wide target snapshot is suitable because at the end of using wide target snapshot, there will be a heavy impact when check processing enables it again. The longer the snapshot takes, the bigger the amount of work to catch up on will be. So I don't want to recommend wide target snapshot as being equal to an LVM file system snapshot in this case. Rightio. And yeah, that's the end of the talk. I ran for a bit longer than I meant to. Whoops, sorry about that. But hopefully you learned all you needed to know about the different options up to the point that let you choose which one you want to focus on. So from here, please focus on what you're going to use and send us any questions if you need to. Cheers. Bye-bye-bye.
Okay, so thank you very much for that talk, Akira. We do have one question that came in from Vishal on what the licensing term for MongoDB Percona server are. So I believe that is something that Rick Vasquez, who is our next presenter, is going to address. So I think, let me just check. I think Rick is there. We have also had a last minute change to our agenda. I believe Kimberly Wilkins, who is one of the newest members of the team to Percona, will be joining us as well. So Rick, I will hand it over to you.
Thank you so much.
Okay.
Let me get started here. Great. So what are we talking about today? Well, today we're going to be talking about MongoDB Atlas and managed community editions. I'm going to explain what I mean by that later on. And really the general theme for this talk is going to be how licensing changed the MongoDB landscape. Coming right off of the question in licensing, how is Percona Server for MongoDB licensed? Currently, it's licensed under SSPL as well, but we'll get more into that in the presentation. So, wouldn't be fun if it didn't start controversial. So, I've heard SSPL is evil. Is that true? In my opinion, no. And the reason for this is really because MongoDB isn't the first, and they're not going to be the last company to really change licensing to fit what their core mission is. And really, if we look at the mission statement for MongoDB, it's to free the genius within everyone by making data stunningly easy to work with. Nothing about that says we want to be open source. Now, when you look at that mission statement, it's really easy to see that the path that Mongo has gone on in Atlas to make data stunningly easy to use. Now they're guarding their code base with SSPL, and what ends up happening is MongoDB being source available instead of open source doesn't make it good, doesn't make it evil, but it does force you to change. It changes the way that you think about deploying the database. It changes the way that you can use the database. And so let's talk a little bit about what database as a service is. So SSPL forced people to change DBaaS with MongoDB. And what do I mean by it forced them to change? It forced people to enter into a commercial licensing agreement with MongoDB. It forced people just not to offer MongoDB services or as a service. And so let's talk about what DBaaS is to understand how that affects the general market. And so IBM has a really good definition for DBaaS, in my opinion. It's a cloud computing service that lets users access and use a cloud database system without purchasing, setting up their own hardware, installing their own database software, or managing the databases themselves. The cloud provider takes care of everything from periodic upgrades to backups, ensuring that the database system remains available and secure 24/7. Now, this is what is taken away from the community explicitly with SSPL licensing. And what we really need to understand from the community editions is how does that affect people's ability to provide services and value add to MongoDB since it's no longer open source, right? It's source available with the caveat that you cannot use it as a service. So let's talk a little bit about managed services. Managed services is the practice of outsourcing responsibility for maintaining, anticipating needs, and a range of processes and functions in order to improve operations and cut expenses. It's a really long way to say we'll run it for you. So DBaaS happens to be a subset of managed services under the larger umbrella of managed services. And the litmus test for whether you're subscribing to a managed service or a database as a service is really as simple as these 5 things. Do you own the hardware that you're deploying the database on? Chances are if you own it, it's more of a managed service than it is a database as a service. There's always a shared responsibility model. So do you have full unrestricted access to the hardware that you own? If the answer is yes, you're most likely dealing with a managed service, not a database as a service. The tooling is not needed to run the database. So if the tooling that whatever subscription or whatever service provider installs on your systems is removed, MongoDB will still run. That is a really good litmus test of whether or not you're dealing with managed services or a database as a service. Are there hands-on to the database, not setting up the database? A really good indicator that you're on a managed service. And then expertise is what you're paying for, and not MongoDB in a licensing fashion is a very strong indicator that you're using managed services as well. So let's talk about community editions. Licensing gets a bit confusing when we talk about MongoDB because of the change. So Percona Server for MongoDB and MongoDB's Community Edition were both AGPL prior to October 16th, 2018, whenever the licensing changed to SSPL. And now currently, there are two editions that are source available, and those are MongoDB Community Edition, which is SSPL licensed, and then Percona Server for MongoDB, which is also SSPL licensed. I do get into the kind of branches of support and some of the things that you can do with the AGPL version. That licensing is not retroactive, so that license applies to all versions of that software before October 16th, 2018. Another really important point to consider is, are you choosing a technology platform or are you buying into an ecosystem? And what do those two things mean? A technology platform is something that you leverage to create value on top of. And it's not typically a choice made from a licensing decision. It uses features and functionality core to the database software itself. And so that's more of the technology angle. Then you have the ecosystem angle, where it's more for enablement. It allows you to do more if you use an ecosystem, and the deeper that you get into that ecosystem. So for database as a service particularly, and managed services particularly, it's important to understand whether you're choosing the technology or whether you're choosing the ecosystem. And with that, let's talk about Atlas. Atlas is in a unique position to provide both a technology platform and an ecosystem. And they did this intentionally with the SSPL licensing. So they are allowed to leverage custom things that MongoDB can only do, and then leverage that as providing an ecosystem for you to have an experience that's controlled by MongoDB. Well, I'm not going to get too deep into the internals of the enterprise editions or the proprietary versions of Mongo and what the differences are. But as far as the ecosystem is concerned, there is some unique functionality in Atlas that's not in any other edition of MongoDB. And that happens to be Atlas Search, MongoDB Realm integrations, that they're tightly coupled in the Atlas world. Atlas's data lake, the RESTful API that's available through Atlas, and then the fully managed BI connector instead of having to manage it yourself. So those are pretty unique value propositions that Atlas has bundled together to really solve the problem of making data really easy to use. What does that come with? And so any database as a service provider, MongoDB included, is going to now have your data on their servers. And I say it's secured. We have not had any breaches from MongoDB's infrastructure. They use data at rest encryption. You have many choices to secure your data, and that is also a shared responsibility. So have there been some people who didn't set a password in their Atlas instances? Of course. Is that MongoDB Inc.'s purview? Absolutely not. They should tell you, and they do, in fact, tell you in the dashboard if you're running in a vulnerable state. I just want to make sure that MongoDB doesn't own your data, but they do own all of the infrastructure that your data now resides on. And that can be said for any database as a service provider. So you can't really have custom replica sets or shard options. So if you are running in kind of a non-vanilla way that's intended by MongoDB, let's say that you have incongruent shards, and some are bigger, some are smaller. That's not really what Atlas allows for you to do. You should deploy everything in 3 node replica sets per shard and grow and scale that way. It is commercially licensed. It is API compatible with the Community Edition, so you can leave. You're not held hostage, and I don't think the intention of Atlas is to ever hold anybody hostage. You don't have any control over the binaries except for version. And what I mean by this is if you wanted to alter the code for your use case, you're unable to do that. Also, if there's a bug or something that is affecting your use case specifically, that hotfix or bug fix resides in the responsibility model on MongoDB's engineering team to deploy that fix for you. And then there's not any features outside of those included by MongoDB that you can leverage on an Atlas type platform. So what are the caveats to moving into Atlas? Well, seamless is only on the way into Atlas. If you're trying to leave Atlas, it is not very easy and not very seamless. You can't just add a node to the replica set and then step down